Hello everyone. I wanted to give you some feedback on lesson 7, which is energy and climate change. I don't think there's a bigger topic right now than climate change. It's something that we need to figure out. It's sort of the mother of all other sustainability problems in that climate change impacts everything else that we talk about in this class, and it's the big kahuna. It's the big one. We really need to figure this out. And now is the time to do it. The technologies are there. It's really just a matter of political will at this point. So hopefully you have a better sense of what the greenhouse effect is and how climate change works and what the enhanced greenhouse effect is, and the fact that the greenhouse effect keeps us alive because it keeps the temperatures warm enough for liquid water to exist. But the enhanced greenhouse effect is the problem, right? So the anthropogenic side of things. Remember, anthropogenic just means caused by humans, so anthropogenic climate change is that aspect of climate change that is caused by humans. To be really, really clear, we don't know the full extent to which humans are impacting the climate. However, the most recent IPCC reports, which are, remember, that's the major United Nations body that produces these, the most, I guess, the premier reports on climate change every few years. They had a set of reports that just came out in 2021 and 2022, and it was the clearest statement on the fact that humans have changed the climate, and that most of the warming that we've seen is due to human influence. So we know that the planet has gotten warmer in the last 150 years. We know the way greenhouse gases work. We know that humans emit greenhouse gases at unusually high rates, unnaturally high rates. Remember all those charts that show the shooting up after the Industrial Revolution of carbon dioxide and methane in particular. So we know all these things. These are not in dispute. And if you put all those together, and then plus the sort of what the science is saying in terms of the published research, there's no doubt anymore that humans are impacting the climate. I mean, 10, 20 years ago, you could say there was some question, but there's just not a question anymore. So we need to figure this out. Humans are the main cause of the warming that we've seen. And remember that it's, global warming, not the greatest term, because hopefully as you gathered throughout the lesson, it's not just warming. Some places will be a little bit colder. It's just extreme weather, right? So this overall climate change is the problem. There's a historic drought going on in the U.S. Southwest right now, like to the point that Las Vegas is worried about running out of potable water. I mean, it's a really big deal, and a lot of that it's due both to population increase and water use increase, but also climate change. It's just been drier and hotter. The forest fires are made worse by climate change. Biodiversity loss is made worse by climate change. So this is a problem that we just have to figure out, and we know that humans are the major influence right now on this changing climate. So a couple of key things I just wanted to make sure are clear. Number one, remember CO2 is the primary gas that we're worried about, the primary greenhouse gas, only because we emit so much of it that it is by far the biggest impact humans have on the climate. Remember that methane is much more potent, about 30 times more potent than CO2 in terms of the warming it causes. But we just emit so much more CO2 that it's the major gas that we're worried about. But methane has become a more prominent gas, especially recently as we see all of these natural gas wells, especially fracked wells that are leaking methane. So methane has become much more important, especially recently, but CO2 is still the big one. So remember that. Methane is more potent, but CO2 we emit much more of. Remember, in order to not be subject to the worst impacts of climate change, we need to be carbon neutral no later than right around 2050, 2060, right around there. Okay, so carbon neutral globally. That means any CO2 that we emit, we have to reabsorb with artificial means. Doesn't mean we have to stop emitting CO2. It just means that anything we emit, we have to absorb with an artificial way. And we can look at carbon capture and sequestration, that's a big technology that's being developed now. But the point is, 2050 is our sort of drop dead deadline. Give or take a few years, we have to be carbon neutral. It's going to take a lot to do that, but we have time. We're kind of running out of time, but we have to take bold steps now in order to achieve that. I mean, you have to turn the whole economy around, basically, like how we get our energy. So very important. And you all can be a part of that solution, both personally and from a, if you from a policy, if you care about this, pay attention to what the candidates are advocating for, because that's where the really big changes happen at the policy level. Number two, the sort of, one of the questions regarded non-climate benefits of reducing CO2. So the idea here is that, if you remember kind of the way we finished up the lesson, that if humans aren't having that big of an impact on the climate, let's say, all these scientists are totally wrong. It's conceivable, but very unlikely. But let's say they're all wrong, and it doesn't even matter if we reduce CO2 or not. If we take all the steps to reduce CO2, which basically requires us using less fossil fuels, there's all these other things that would be beneficial. We would have cleaner air. Think about it, like all the particulates and the pollution coming out of these gas vehicles, not going to be there, or very much less. The power plant emissions like mercury and nitrogen oxides, all these toxins that are not CO2 but still emitted by power plants, they would be lessened. All of the environmental damage from mining and doing things like drilling for oil and fracking and doing deep sea wells and all these sorts of things, tar sands up in Canada, all these environmentally destructive extraction techniques would be minimized. Now, granted, we have to extract things to make solar panels and wind turbines and so forth, so it's not, there's no free lunches here, but you'd have more democratically provided energy. So like you'd have much more control over your energy. Like if everyone has a solar array on their roof, they have more control. You're not reliant upon these big corporations and big companies. So there's a lot of these other benefits: cleaner air, cleaner water, more democratic energy sources. A lot of positive health impacts would occur if we can get rid of a lot of these pollutants that end up in the air. So the idea is that no matter what, it's a win-win basically. And to be clear, people in the fossil fuel industry, of course, there's going to be job losses there, but the economy just has to shift to the renewable jobs. And I'm not here to minimize like coal miners or anything. We have to think about them and the responsible plans, these transition plans, or what's called just transition, is like we recognize that people are going to lose jobs. They're going to lose work, sometimes really good paying jobs, and we need to help them transition to new jobs. So that's really important. Number three, in terms of externalities, so there was a question about externalities. So just remember, an externality by definition it's something that occurs to somebody that's not involved in a decision or a transaction. Okay, so it's a third party is impacted. So with climate change, it's one big externality for the most part, because most of the impacts that are resulting from your decisions or these companies' decisions to emit greenhouse gases, it's not impacting you, it's impacting someone in another country or someone in a different location or a future generation. Okay, so to the extent that it impacts you, that's not an externality. Okay, by definition, that's internalized. So that's an externality, but remember, the positive or negative externality, for it to be a negative externality, the cost of that impact is not included in the price. So with climate change, if I drive to work and I emit CO2 out of my tailpipe, I've paid for the gas, so I get a service from that gas. But any contribution that my emissions make to climate change are almost entirely externalities, because number one, they happen to other people in other places or in the future. Number two, because I don't pay for that, there's no carbon tax in the gas. There's no like, okay, you're causing this much damage, so your gas cost is going to increase by this much. Okay, so it's an externality because it happens to someone else. It's a negative externality because it's not included in the price. So someone else is paying for it and I'm not. Okay, so that makes it a negative externality. Okay, I know it's a little bit confusing, but just consider externalities are just anything that happens to somebody that's not involved. But to be positive or negative, it includes a cost. So if it's positive, that means there's a benefit that happens to other people. and that's not included in my cost. Negative, which is more common, means that there's something bad happens to somebody else somewhere else, and that is not included in the price that I pay. Okay, so if we paid the true cost of electricity generation, for example, it would be much more expensive because there's all these negative health impacts. There's the climate change impacts of generating electricity through these power plants. That's not included in the price, so it's a negative externality. Okay, so it has to be disincluded from the price. Number 4, remember, natural gas is almost entirely methane, right? So if natural gas leaks out, that's methane, which is really bad for the climate, 30 times more potent than CO2. So just be careful. Methane is not CO2. If you burn methane, it emits CO2. Methane itself is just methane. Well, it's CH4. Okay, so natural gas is methane. If you burn natural gas, it generates CO2. If you just leak it out, it leaks out methane. Okay. There's some, number 5, we had a little question on nuclear. Remember, nuclear is just carbon-free because you don't burn the uranium. You use fission, right? We split the atom, which it's not combustion. It's not a carbon. It's not a hydrocarbon, right? So coal, oil, natural gas, wood pellets, biomass, they're all made of mostly carbon and hydrogen. So when you burn it, it emits CO2. With nuclear, you just split it like it's that easy, but you split it, you don't burn it, which means it's carbon free. Okay, so this is a really huge debate in the sort of sustainability world and the environmental world is, should we promote nuclear? Because nuclear waste is really bad. It lasts for thousands of years, very toxic, very dangerous, very deadly. However, it's carbon free and it's a really powerful energy source. So how much nuclear should we use is a really important question and a huge debate right now in the sustainability world. I wanted to, number 6, briefly go over the difference between adaptation and mitigation. So in terms of our approaches to addressing climate change, there's sort of 2 main approaches. Number 1 is mitigation. So mitigation means preventing emissions from happening. Okay, that's the stuff we normally talk about. Number 2 is what's called adaptation. So adaptation recognizes that there's going to be some impacts. Sea level rise is a really good one. The state of Delaware has a carbon adaptation plan as part of their climate change master plan. And they know that sea levels are rising, so different towns and cities in the state of Delaware are figuring out, like, okay, as the sea level rises, what are we going to do? That's adaptation. Like, things are going to happen. How do we adapt to those changes? How do we adapt to a warmer world, a world with different growing seasons, etc.? That's adaptation. Mitigation is like, stop it from happening. Okay. Also, the term climate justice is really important from a sustainability perspective. And there's different aspects to climate justice. The sort of 2 main, I guess, sides of the coin are, number 1, most of the people that are least responsible for emissions are most impacted. That's the main part of it. And then on the flip side of that coin, the people that are most responsible are generally least impacted. So you have, if you look at the maps of who's going to be most impacted, it's going to be these lower income countries across the world, less industrialized countries, like a lot of the countries in Africa, sub-Saharan Africa in particular. They're most impacted because they don't have the resources as much to adapt to these changes. And yet, if you look at who's responsible for emissions, they're the least responsible. On the other side of the coin, the U.S., with 5% of the population, emits like 15% of the emissions. So we're largely responsible, and we will not be impacted as much. That's not to say people in the United States won't be impacted. Of course they will, especially low-income folks on the coast, folks that can't afford to move away from these areas. However, in general, those most responsible for climate change are least impacted, and those least responsible are most impacted. That's climate injustice. And regarding emissions, remember that China emits more emissions than any country in the world, so that's important to address. And China is on board with all of these emissions targets by 2050. The U.S., however, out of all the major emitters, we're number 2 in terms of total emissions, but out of the major emitters, we emit almost the most per capita. Okay, so Per capita means per person, so if you want to really be fair about who's most responsible, you want to look at not just the total emissions, but the per capita emissions. And while China has more total emissions, they also have 4 times the number of people, so if all were fair, so to speak, they would have 4 times the emissions, but they don't. So the average American emits 3 to 4 times as much as the average Chinese, about 8 times as much as the average Indian. And then you look at like a lot of the, sort of less industrialized countries, and we're 10, 20, 30 times more than a lot of these other countries per person. So the per capita is just as important as the total. Lastly, just want to briefly reiterate how the greenhouse effect works. There seemed to be a little bit of confusion on this. There's greenhouse gases in the atmosphere. Remember, sunlight comes through. Sunlight is shortwave radiation. The shortwave passes right through the greenhouse gases in the atmosphere. If it bounces off of something on the surface, it remains shortwave and just will primarily just go right back through the gases, right? So if its shortwave comes in and is reflected off something like a light-colored surface, it's going to go back out most likely. However, if it comes in as shortwave, passes through the gases, and then is absorbed by something, so if I would step outside today, it's a nice sunny day, that sunlight would hit my skin and the sweatshirt and all that, and it would warm my skin up, it would warm the shirt up, it would warm my pants up, whatever, and then I actually radiate heat back out. That heat that I radiate is shortwave, or long wave, excuse me. So it comes in as shortwave. If it's absorbed, re-radiated out as long wave. And then when that long wave goes up, the greenhouse gases are really good at absorbing that long wave radiation. So they absorb the long wave, they get warm, and then they radiate in all directions, including some of it down. And so if you think about it, if there's no gases in the atmosphere, if something comes in, is absorbed, and there's nothing to absorb it on the way back up, so if it's absorbed, near the surface and then it goes back out, there's no gases there, that long wave is just going to go out to space. And so it's not going to be held back in toward the surface. But because we have this huge layer of greenhouse gases in the atmosphere, they absorb that long wave radiation, which then radiates the long wave back down. So the key to greenhouse gases is just their physical property is they allow short wave to pass through them, but they absorb long wave. That's what a greenhouse gas is. And so when the short wave comes in, which is sunlight, just goes right through. If long wave comes back up, it's absorbed, and then some of it's held back in. And that's how the greenhouse gases keep the planet warmer than they would be otherwise. Okay, I think that's it. I know it's a lot, but this is a really important lesson, and there seem to be a couple of points of confusion. Hopefully that helps clarify things, and I'm, of course, happy to follow up if you have any questions.